Hi everyone. In this lecture, I will discuss quantile regression. Why do we use quantile regression? How does it differ from linear regression? What are its advantages? Linear regression gives a partial view of the relationship between dependent and independent variables. Since it is based on the conditional mean function of dependent variable. Quantile regression, on the other hand, facilitates the description of the relationship at different points of the conditional distribution of dependent variable. We can consider the relationship between dependent and independent variables at different quantiles. Quantile regression has several advantages. It is robust to outliers as compared to linear regression. Being semi-parametric, it is also robust to non-normality, and it provides a very rich description of data. Now, I have the data for 309 listed Indian companies, and these are the variables. This is, of course, the data relates to firms. Leverage is my dependent variable. ROI, grow, uniqueness, tangibility, current ratio, Tobin skew, and log of total asset are my independent variables. My commands are in what we call log file, do file. So this is a do file which I can open. So recently I had entered all commands in a do file, and I can easily use these commands to obtain results. I think you should make this as a practice, that you should create a do file, and before you start your estimates you should put all commands in do file. Then it will be easier for you to execute them. Also, you would remember that what commands you have to use in your estimates. Now, let us first run. Now, let me describe here that what are the kinds of commands which we are going to discuss in this lecture. Of course, when you use this command, my data file is in D drive, and therefore I can use this command to get the file which is already there. Then we will first run OLS regression so that we could compare it with the quantile regression. Now, in case of quantile regression, you would like to see what is the distribution of your dependent variable, okay, over quantiles. So there is a command which is called qplot. Qplot command can be used for this purpose. Of course, you will have to download it because it is not in built-in stata. After that, you run your regression for quantile. Now, the command is to start with Q for quantile regression. So Q, reg, and followed by your variables. Remember, when you don't put anything here after your independent variables, now by default, you will get quantile regression for median. Now, and then of course, the same command I have written here in the second line, but I have put after comma no log. Actually, quantile regression will go through certain iterations. If you don't want to see output with regard to iterations, then you use this second command. Let's run them together and you will see the results. I have deleted them rather than executing them. So let me execute them. Here is this execute selection. And now I have got the same results, except that in one case I have iterations and in another I don't have them because I use this command, additional command here, no log. Now you may be interested in running your quantile regression simultaneously. For example, you may be interested in quantile regression for quartiles, that is 0.25, zero point 0.5, and 0.75. Now for that, the only difference now is that the command is the same except that here we write S. So SQREG followed by variables after comma, no log because you don't want to see iterations, and then you put Q for quantiles. Whatever quantiles you want to get estimates, you can put them within parentheses. So here I am writing 0.25, zero point 0.5, and 0.75. If I execute this command, I will get the results. Now here you will get it. It will take a little time to make these estimates. Now you find that you have got your output for 25, 50, and 75. You can look at the coefficients and their significance. Now for Tobin Q, for example, what you find here is that this one is insignificant, but here it becomes significant. In both cases, you have negative sign, but then it becomes significant here. Now here you have growth as insignificant, uniqueness is significant, well, you may say 10%. ROI is of course is significant, but then when you look at the tangibility, this is also significant at 1%. Current ratio is significant 1%. Now for quantile 50, what you find is that your Tobin Q now becomes significant. Here it was insignificant. Similarly, it again becomes insignificant. So you can compare and you find that over these quantiles, your coefficients may change. Now, you would like to know whether these estimates are same or not. Okay, is there equivalence? All these estimates are equivalent or not? For that, you can once again, very quietly, we will run the regression for all of them. And so here, if you write QUI, or you may write full QUIETLY quietly, and then you run SQREG command, you shall not get output. It would be there. So if I execute it, now here there are results which we won't see. Now you can test them for the equivalence can be tested for different, let's say, variables. Now, if I am interested in testing whether the estimates of quantile 0.25, quantile 0.5, and quantile 0.75 same or not, so I can execute this particular command, which is test between parentheses. You write Q25 equal to Q50 equal to Q75, and then you write the variable name. So let me execute it, and then we find that the f value is insignificant. So this means that we cannot reject the equality of estimates assumption here. Now, you may like to compare, let's say, your estimates of OLS as well as quantiles across quantiles, etc. Now, in that case, actually, the command which you can run is ESTSTO, that is estimate stored, let's say model 1, and again we run them quietly. Now REG and then variables, this means that what you are running is linear regression. And then similarly, we can run these regressions for all other quantiles. I can execute all of these commands together. And again, I will not see the output, but it's there. Now, if I run this command, which is esttab, and then followed by the model 1, 2, 3, 4, because we estimated 4 models, and if I execute this command, so I'll get a table which gives me comparative picture. Now, here is the table. Now, this first one is for OLS, followed by quantile 0.25, zero point 0.5, and 0.75. Now, you can compare the coefficient and even their significance. So, this gives you a comparative picture of your estimates. Now, similarly, you can see effects of independent variables across quantiles, including OLS. Now, for that, once again, we run this regression of quantile. We can run 0.5 or 0.75 or 0.25, but we shall get the answer and we will get a graph. So if I run this one quietly and execute it, I have to run only the command actually, so by mistake. So quietly you have estimated your median regression. Now you have to use a command which is grqreg. Again, you will have to download this command because it's not built in as data. This time you will get a graph and you can see the behavior of various independent variables across your quantiles. So let us execute it. You will get a graph. This will take a little time to see the graph, but in the graph you can very clearly see the picture of your estimates of variables and as compared to your OLS. Let's wait, it's taking time. Now this graph is there, so you can look at this graph. Now what do you find? Of course, it gives you even the intercept. Now these are your quantiles and this is your Tobin Q. What you find is that your estimates of quantiles are parallel to your OLS line actually. This is your OLS, dotted line is your OLS. And here also you find that they are moving parallelly. There is here, again, it deviates here somewhat, but then again, it deviates here, and then it is same in many places as your OLS. Similarly, you can see the behavior of all of them. Here you find that your current ratio, of course, it moves away from your OLS line. OLS line is fixed because it is mean, it is conditional mean where you find the relationship. But in quantiles, your quantiles are different. So these are the important commands which you must remember and practice if you want to understand quantile regression.